Hello and welcome to this video on topic 6, groups of the periodic table. We'll be looking at group 0, which is the noble gases. So as usual, make sure your phone is switched off, you're not playing on it, it's not distracting you, and you have a pen and paper ready to take some notes and answer the questions. So the group 0 elements are, I'll show you where they are. They are these ones here. They're at the end. Sometimes they're called group 8. And we go from helium all the way down to radon. We don't need to include this one down at the bottom. But as you can see there, we have 6 of them. Now you don't need to know them because you're given the periodic table in your exam. It is at the end of the paper, so you can refer to it on there. Now they are known as the noble gases. So they are known as the noble gases. Again, you will have a question in your exam asking you to name one of the groups, either group 1, group 7 or group 0. Group 1 is our alkali metals, group 7 is the halogens, and group 0 or 8 are the noble gases. Now they weren't on the early versions of the periodic table because only recently they had been discovered. Now they all have similar properties. They're all in the same group for a reason. It's because they have similar properties. Now they all have a full outer shell of electrons. That is 2 for helium. That's a slightly different one. The rest of them will have 8 electrons on their outer shell. That's why they're sometimes referred to as group 8 or group 0. So the outer shell has no electrons, or it has a full complement of electrons, hence why it's in group 8. And they do not form ions, and that's because they already have a full outer shell. So the outer shell is already there, it's full, it doesn't want to add anything else to it or lose anything from it. We've drawn there our first 3 noble gases. We've got helium, neon and argon. We write out the electron configuration. Helium is 2, neon is 2 and 8, and argon is 2, 8, 8. We've got 2 in the first shell and then 8 in our next shell, and argon 8 on the third shell as well. Now they are what we call inert. Now the word inert means unreactive. It's a word you're likely to see in your exam. So if you see it, you now know what it means. It means they are unreactive. And that is because they have a full outer shell of electrons, so will not gain or lose electrons easily. I've said easily there because it can happen. We can make it happen, especially with some of the ones further down. With a lot of energy, we can take away electrons, but it takes a lot of energy to do that. So we do refer to them as inert because naturally they are unreactive. In the exams, you need to have both of these points. You need to say they have a full outer shell of electrons and that they will not gain or lose electrons. So you need 2 different points. So they have the full outer shell of electrons. So we've got a full outer shell of electrons. That is 1 mark. I'm trying to highlight there, it's not going very well. And they will not gain or lose electrons. That's our second mark there as well. So we need both parts to get the marks. So you need both mark points to get the mark. So you need both points to get the marks. Obviously, if you only remember one of them, 1 mark is better than none. But obviously, we're aiming for those top marks. We want to get both points in there to get both marks. Now, as we look at them, they have some uses. The most common one you probably know of is helium. And we've got some balloons there that have been filled with helium, and they have risen up. You'll know if you have a helium balloon, if you let go of it, it flies off into the air. Now, that is because helium is less dense than air. So it is used in balloons or airships because it allows them to float in the air. And we want to say it's less dense than air, not that it has a low density. It is less dense than air. We want to be very, very specific with our answers. So it is less dense than air. So it's that part there. It's less dense than air. is our key part we want there. It is also non-flammable, so it will not catch fire. Very, very useful in an airship. So there was one years ago called the Hindenburg, and it had hydrogen in it. And hydrogen is also less dense than air, but hydrogen is very flammable. So a hydrogen airship can catch fire, whereas a helium airship will not catch fire. Got a picture there of someone doing some metal welding. So they're using a very, very high temperature to join two bits of metal together. When they do that, they use argon as what's called a shield gas. And that goes around, they do it in an argon environment, and it will protect it. It's inert, so it's unreactive, so it will not react with the metals. So they use a noble gas called argon because it will not react with the metals. And finally, in filament light bulbs, so we're seeing less and less of these as we're moving sort of more energy saving ones and LED light bulbs. But a filament light bulb has a metal wire in where we pass a current through it. That metal wire gets very, very hot. And if we've got heat, we've got a fuel source, which is our metal. If we had oxygen, we would cause a fire. So we want to make sure there's no oxygen in there. So they replace it with either argon, krypton, or xenon because they are very unreactive or inert. So they stop the metal wire in the filament burning away. And it means our light bulbs last a little bit longer. We're now going to have a look at the boiling points. I've got a table there showing the boiling points of the group 0 elements, and they're going down in order. So we've got helium, neon, argon, krypton, xenon, and radon. Now their boiling point is where they turn from a liquid to a gas. We can see there that at room temperature, which is about 20 degrees, they're all gases. Radon turns to a gas at about minus 60 degrees, so you have to get incredibly cold before it turns to a liquid. Helium, right at the top, is pretty much down as close to the coldest temperature we can get, which is minus 273. We can't really get much colder, and that's the point where it turns into a liquid. It is very, very low boiling point. So we need to know the trend in the boiling points, and we'll be able to describe it as well. So going down the group, the boiling point increases, so we can get that from the table. It's a statement we need to know. Now our reason why is because the atoms get bigger going down the group, so the intermolecular forces increase. So our atoms get bigger, our intermolecular forces increase. Now intermolecular force is what holds them together in either solid or liquid, and that has to be broken for us to overcome it. So the bigger the molecule, the bigger the intermolecular force. Now that we've just said that, so the more energy it takes to overcome those forces and change state. Now our intermolecular force is not a covalent or an ionic bond or a metallic bond. It is the force between molecules. So you'll see it in covalent molecules or non-metals, and is the thing we need to overcome to change the state. It is not breaking the covalent bond. That is very, very strong. Now these molecules don't have a covalent bond because they are single molecules. But when we want to overcome that intermolecular force, that is what we are breaking. So if we have a look at some of them, so I've got some helium atoms here. We'll have them there. What we have in between them is an intermolecular force. Now this is very weak, especially compared to covalent bonds, ionic bonds, metallic bonds. They're not going to break particularly easily, but our intermolecular force will break. Now if we draw a slightly bigger atom, so we've got neon, our atoms are bigger, so our intermolecular force is slightly stronger than in helium. So our intermolecular force This one is stronger than helium's. But still very, very weak. It doesn't take a lot of energy to overcome it. You need to know that going down the group, the boiling point increases, and our reason why. So we've now got the density. As you can see, as we go down the group, the density increases. Helium has the highest density, or the lowest density, sorry, and radon right at the bottom has a much, much higher density. Our statement again, going down the group, the density increases. That is a statement. We can try and remember that fact. They may ask it in the exam. Our reason why, and that is because our atoms have a bigger atomic mass going down the group. As we go down the group, they get heavier. The mass increases. Now, this bit gets a little bit complicated, but the number of atoms per unit volume, so per square inch, per centimetre cubed, whatever volume we've got in a room, will stay the same. That's always the same for every single gas. So if I had 5 helium atoms in a space, I could also fit in 5 radon atoms within that space. The number of it stays the same. Because the mass increases, the density does too. I just think I should have put that equation in. We've got our equation. You've probably done it in physics. So your density is equal to your mass divided by your volume. I could say, oh, you can clearly work out from this that the density will increase as the mass increases, but we can. If we have a mass of 1 and a volume of 5, I've got 1 divided by 5, and that equals 0.2. So my density would be 0.2 grams per centimetre cubed. If my mass was 2, so I doubled the mass, but kept the volume the same, my density would now be 2 divided by 5, and that is 0.4. If I had 10 atoms in there, and the space is still 5, I've got 10 divided by 5, and that is 2. We can see there that my density is increasing as my mass increases. So increase the mass, the density increases as well. I've got 3 questions here for you to try and remember. So 2 of them just listing the noble gases in order of increasing boiling point and density, and 1 of them explaining why the noble gases increase in boiling point. So pause the video, have a quick go at answering them. So you should now only be watching if you have answered these questions. So we'll look at the answers. So our noble gases in order of increasing boiling point. We've got helium, neon, argon, krypton, xenon, and radon. So it's those 6 noble gases. Question 2, I want to explain why the boiling point of the noble gases increases going down the group. I want to say the atoms get bigger going down the group, so the intermolecular forces increase. And we've explained it a little bit more. The bigger the molecule, the bigger the intermolecular force, so the more energy it takes to overcome those forces and change state. And that would get us all of the marks in an exam. And finally, we want to list the noble gases in order of increasing density. Again, for that, we've got helium, neon, argon, krypton, xenon, and radon. So they're increasing in density going down the group. Well done if you got those correct. And finally, I've got an exam question for you on the noble gases. So it's 2 questions. There's not many of them on there because there's not much to learn about our noble gases, which is quite nice. If you do get a question, you know you can ace it. So explain using figure 3, that's the diagram there, why helium is inert. And then part 2, helium is used to fill balloons. State 1 property of helium, apart from it being inert, that makes it suitable for filling balloons. So please pause the video now and try and answer those questions. So you should now only be watching if you've answered those questions. We'll look at the answers. So explain using figure 3 why helium is inert. You might notice it's worth 2 marks, so we want to get 2 points on there. Remember back at the start of the video, I did tell you how to get those 2 marks. If you're not sure what they were, go back and look at it again. So helium is inert because it has a full outer shell of electrons. So helium does not need to gain or lose electrons. My marks there, I get 1 mark for saying it's got a full outer shell, and my second mark for saying it does not need to gain or lose electrons. I want both parts there. And my second part, helium is used to fill balloons. State one property of helium, apart from it being inert, that makes it suitable for filling balloons. This one I put, it is less dense than air. Again, I would get my mark there. If I was to say it has a low density, so a low density, that answer would be wrong, because a low density does not explain why it's being used to fill balloons. It's because the density is lower than that of air. So it is less dense than air. We need to be really, really clear with our answers so that we get all of the marks. Well done if you got both of those questions right and got all 3 marks. You've set yourself up really, really well for the exam. You're going to do absolutely fantastically. Have a good rest of the day. Take care. Bye-bye.